Hi guys, it's Mrs. Doriso, and we are starting a lesson on 6.1 from the Blue Book, Relations and Functions. In the very first part of your notes, I would like you to recognize that the ordered pairs are what we are using to show inputs and outputs. So the inputs, if you'll notice, are labeled in blue. These are inputs, and these are actually the x coordinate of the ordered pair. The outputs, labeled in red, are actually the y coordinate of the ordered pair. So just keep that in mind as we progress through these notes. And now we begin to define a relation. A relation pairs inputs and outputs. Remember, inputs are the x value and outputs are the y value. A relation can be represented by ordered pairs or a mapping diagram. These are ordered pairs. You're used to these. You can put them on a number line. Now in your notes you only have this part. There's the cat. I knew she would show up. She knows I'm screencasting. You can take these ordered pairs, you can put them on a plane, a coordinate plane. So I'm going to do that right now. We have the first one 0, 1. So we go over 0 and up 1. There's a point. That takes care of that one. And the next one we have 1, 2. There's a point. And the last one we have 2, 4. And there's a point right there. So if we were to draw a line through these, it would look something like that. You can also represent a relation by using a mapping diagram. In this case, you're mapping the x coordinate over to the y coordinate. So here's 0, 1, here's 1, 2, and here is 2, 4. For this first example, what they want you to do is just recognize that you can make ordered pairs from looking at a mapping diagram. Now remember, ordered pairs look like this. This is an ordered pair. You don't have to write this if you don't want to, but it looks like this. Now these are also represented by the inputs and the outputs. So let's create the ordered pairs that are represented by these mapping diagrams. The first one maps a 1 to a 3. And the next point would be 2, 6. The third point, yep, you're probably already ahead of me, is 3, 9. And the last one is 4, 12. So that takes care of the first example, letter A. Now we're letter B. This maps 0 to 0. And then we go 2 to 1. And then we also go 2 to negative 2. And finally 4 to negative 3. Now what you're going to find out in the next section is that this, I'm going to change the color, that this is actually a function. We're talking about relationships and functions. And this is not a function. You'll see why in just a little bit. But the key is we have one of the x's that is mapped to 2 y's. And if that happens, then it cannot be a function. But that's coming up, so just hang tight. Now it's your turn. I'd like you to pause the video and I'd like you to do these problems on your own. All you're doing right now is listing the ordered pairs that are represented by the mapping diagrams. Now here's where we begin to define what a function is. In your notes, and I don't have it here, what you have is a definition that says a function relates one input with exactly one output. So what that means is for every value in the inputs, that would be x and y, you can only have one value in the output that is linked to the input. You'll see what that means in just a second. But if you'll notice, let's look at number A. We have the ordered pairs -9, 0, we have negative 2, 5, we have 5, 10, and we have 12, 10. Now in this case, we have one input that is mapped to an output. This is a function, and you'll see in just a second. What I'm looking at is I am making sure that I do not have two lines coming out of the input. So each input only has one line coming off of it. It doesn't matter how many lines are coming off of the output, but as long as I only have one line coming from each input, then it is a function. Let's look at the next one. Again, we're looking to make sure that we only have one line. So I'm going to write one line with a question mark, and let's take a look. We have negative 2, 4. We have negative 1, 4. We have 0, 5, but we also have 0, 6. And this is the part that tells us this cannot be a function. The reason is, if I have a function, I cannot have two x values or two inputs that give me different outputs. So this is not a function. The key again is you are looking, I'm going to highlight this time, you are looking here at the inputs and you're making sure that you only have one line coming off of each one. So this one works, okay, but this one does not. So it is not a function. And now we test what we just learned about trying to decide if the mapping diagram is a function. What I'd like to do is have you remember that we are focusing on the inputs. For the inputs, we're making sure that each input only has one line coming off of it. So I'm going to say one line with a question mark. So let's check this. We have 115, we have 230, we have 345, and we have 460. And there's only one line coming off of each of the x values, or each of the input values. So yes, this is a function. Now the next trick is, let's go down to letter B. What we're trying to do is describe the pattern of inputs and outputs. And this is where we begin, as we get further on into the chapter, to define what the formula for the function is. Now what we see is that as each input, or x, increases by 1, there's 1, then the outputs, or y, increase by 15. So let's just describe that. As x increases, there's just an arrow, by 1, then y, or the output, increases by 15. And that's really all you need to do for that. Now it's your turn. I would like you to do two things for this. You need to pause the video or stop the video, and you need to first decide if this is a function. For the second thing, see if you can come up with a pattern. You may not be able to find one, and that's okay. But what I'd like you to do first is decide if this is a function, yes or no. By the way, if it's not a function, you will not see a pattern. When you're done with this set of notes, I'd like you to move on to the next task, which is a Big Ideas assignment. It is in Big Ideas and marked blue 6.1 practice. Be prepared tomorrow to show me your notes so that I can see that you did the on your own problems.